On this 2015 to 2025 F150 with the 3.5 EcoBoost, P0234 means the PCM is seeing an overboost condition. In plain language, boost may be higher than what the PCM is commanding or higher than its calibrated limit. The truck may go into reduced power, may feel inconsistent under load, or may set the light after a hard pull. Broadly, this can involve boost control wiring, bypass valve operation, wastegate control, intake or charge air leaks and restrictions, exhaust restrictions, turbocharger mechanical condition, or aftermarket changes. Start with the basic system checks, then scan the vehicle. If circuit codes are present, handle those before chasing this overboost performance code. You may need to drive the vehicle to reproduce the conditions that set the code. Once P0234 is the path you are following, do a careful visual inspection before touching the meter. Look at the turbocharger wastegate control harness and the bypass control harness for correct connection and routing. Check for air leaks around the tubing and intake manifold, poor electrical connections, exhaust damage or leakage, turbocharger oil leaks, restricted or damaged oil return tubes, visible turbocharger damage, missing or disconnected wastegate linkage or retainers, and the wastegate motor linkage adjustment and assembly. Move the wastegate linkage slowly with steady pressure toward the motor and then away from it. If you find a real concern here, repair it, clear the PCM DTCs and repeat the self-test. If the visual inspection is clean, move into the circuit checks. For the turbocharger bypass valve circuit, key off. Disconnect the TCBY valve connector, then key on and check voltage at C1622 pin 1. This step applies to multiple components, so only test the circuits that match the vehicle and component you are diagnosing. If voltage is greater than 10.5 V, continue. If it is not, repair the open circuit, clear the PCM DTCs and repeat the self-test. Next, key off and disconnect the PCM connector. On the 3.5 EcoBoost path, check resistance between C1622 pin 2 and C175E pin 102. If resistance is less than 5 ohms, continue. If not, repair the open circuit, clear the codes and retest. Then check for short to ground at C1622 pin 2. You want resistance greater than 10,000 ohms. If it is lower than that, repair the short circuit, clear the codes and retest. After that, key on and check C1622 pin 2 for a short to voltage. If any voltage is present, repair the short circuit, clear the PCM DTCs and repeat the self-test. If no voltage is present, check the bypass valve component resistance between C1622 pin 2 component side and C1622 pin 1 component side. The expected range is 560 ohms. If it is outside that range, install a new component in question, clear the PCM DTCs and repeat the self-test. If the component and basic circuits pass, reconnect the PCM and TCBY valve connectors, key on, and watch the related bypass and wastegate position PIDs while you wiggle, shake, and bend small sections of the harness from the component back toward the PCM. A PID change means the harness movement is affecting the circuit. Isolate that spot, repair it as needed, clear the PCM DTCs, and repeat the self-test. If the harness check is steady, lightly tap the suspect component to simulate road shock and wiggle its connector while watching the same PIDs. If the PID changes during that check, install a new component in question, clear the PCM DTCs, and repeat the self-test. If there is still no change, move on to the system performance checks. Now step back and look at the turbocharger system as an air and exhaust system. Check the air filter element and housing for contamination, restriction, or water intrusion. Disconnect the air intake and check for restriction or water intrusion there too. Re-inspect the turbo control wiring, bypass wiring, intake tubing, manifold area, exhaust condition, oil leaks, turbo oil return tubes, and turbocharger condition. Also check the charge air cooler system for leaks, and the CAC and intake air system for restrictions. Look closely for aftermarket exhaust parts, performance chips, turbocharger changes, tailpipe changes that increase exhaust restriction, or a restricted exhaust. If you find a concern, repair it, clear the PCM/DTCs, and repeat the self-test. If a plugged or restricted exhaust is the concern, pause this overboost path and diagnose that restriction before continuing. If nothing shows up, smoke test the CAC and intake air system. Disconnect the CAC tube from the throttle body, temporarily plug the CAC tube outlet, bag the air filter to stop airflow out the intake port, reinstall it, connect an approved smoke machine or equivalent to the intake air system with the correct adapter, fill the system with smoke, and check for leaks or restrictions. When that step is complete, remove the plastic bag, reconnect the CAC tube, and reinstall anything removed for the test. Any leak or restriction gets repaired, then clear codes and retest. If the system holds, check bypass valve operation. Start the engine, command the bypass off, command the wastegate duty cycle to 0%, bring engine speed up through the commanded RPM control, and record the TCBP PID. Then command the bypass valves on and record TCBP again. On vehicles without the RPM command PID, use the accelerator pedal to hold the engine RPM at approximately 2,000 RPM. The TCBP PID value may decrease by 0.97 kPa 0.14 psi or less when the TCBY valve is commanded on, so the key is whether it decreases when commanded. If it does, continue. If it does not, install a new turbocharger bypass solenoid, clear the PCM/DTCs, and repeat the self-test. For vehicles without a TCBY valve, follow the passing path and continue. Next, key off and inspect the turbocharger wastegate actuators. Look for damaged, disconnected, or missing linkage and retainers. Move the linkage slowly with constant force toward the wastegate motor and then away from it. The motor requires slow, steady force to move the linkage, so do not snap it back and forth. Also inspect the wastegate motor harness and connectors for housing damage, connector damage, cross circuits, pushed-out pins, corrosion, and incorrect connections. If anything is wrong, repair it, clear the PCM/DTCs, and repeat the self-test. If that area is clean, inspect the turbocharger compressor wheel and housing. The wheel should spin freely without noise, vane damage, out-of-balance indication, or debris in the housing. If a concern is present there, install a new turbocharger assembly, clear the PCM/DTCs, and repeat the self-test. If the turbocharger inspection passes, continue into the wastegate motor circuit checks. With the key off, disconnect both turbocharger wastegate motor connectors, then key on and check the VREF and SIGET circuits for the applicable component. On this path, voltage between C1896 pin 3 and C1896 pin 5 should be between 5V. Watch probe polarity during this measurement, and only test the circuits that apply to the component being diagnosed. If the voltage is not in range, pause this path and continue with the appropriate VREF diagnostic path instead of guessing. If it is in range, key off, disconnect the PCM connector, and check for opens between C1896 pin 4 and C175E pin 78. C1896 pin 1, and C175E pin 25, and C1896 pin 2 and C175E pin 4. Each should be less than 5 ohms. If not, repair the open circuit, clear PCM/DTCs, and repeat the self-test. Then check those circuits for short to ground. The resistances should be greater than 10 k ohms. If not, repair the short circuit, clear codes, and retest. After that, check for circuits shorted together across the listed C1896 pin combinations. Those resistances should also be greater than 10 k ohms. If not, repair the short circuit, clear codes, and retest. Then key on and check C1896 pin 2, C1896 pin 4, and C1896 pin 1 for a short to voltage. If any voltage is present, repair the short circuit, clear the PCM DTCs and repeat the self-test. If no voltage is present, key off and measure wastegate motor internal resistance between C1896 pin 2 component side and C1896 pin 1 component side. The expected range is 190 ohms. If it is outside that range, install a new turbocharger wastegate motor in question and reset KAM. If it is in range, reconnect both wastegate motor connectors and the PCM connector, key on, and monitor W-gate A POS-PCT and W-gate B POS-PCT while wiggling, shaking, and bending small harness sections from each motor back to the PCM. If the PID shows a concern, isolate and repair it, clear codes and repeat the self-test. If no concern shows up, move to the position check. For the wastegate position check, cycle the ignition on, off, then on. Monitor W-gate A POS-PCT and W-gate B POS-PCT. Press the accelerator pedal fully to the floor, wait 3 seconds, and record the PID values. Then release the pedal fully and immediately record the values again. Make sure the pedal is fully applied and fully released when you capture the numbers. The PCM commands the wastegate motors to follow pedal position until the pedal is fully released, and some failure management strategies may limit operation if a harness or component concern is present. Compare the recorded values to the expected fully applied and fully released ranges. If they are not in range, adjust the turbocharger wastegate motor linkage using the correct adjustment procedure, clear DTCs, and repeat the self-test. If the code comes back or the linkage is not adjustable, continue to the final connector check. For that final check, disconnect all PCM connectors and both turbocharger wastegate motor connectors. Inspect for pushed-out pins and corrosion. Reconnect the PCM connectors and both wastegate motor connectors, making sure every connector is fully seated. Then verify whether the concern is still present. If it is still present, install a new turbocharger wastegate motor in question and reset KAM. If it is gone, the system is operating correctly at this time, and the concern may have been caused by a loose or corroded connector. Keep repair verification separate from testing. After any repair called out by the path, clear the PCM DTCs and repeat the self-test. Then confirm the overboost code stays gone under the conditions that originally set it. The takeaway is simple. For P0234, do not jump straight to a turbocharger. Prove the wiring, prove the bypass response, prove the air and exhaust path, prove the wastegate actuator and motor circuits, and only then make the component call the test supports. For more diagnostic training, visit stepdiagnostics.com.